Well, first, good morning, everyone. Welcome. Thank you for joining the second day of the Aspect user meeting. And our first talk today is by Yimin Yin, and it's on elASPECT, a variant of Aspect for elasticity-based problems. And Yimin, the floor is yours.
Okay, so I'll start.
Yes, please go ahead. Thank you.
Okay. Hi everyone. It's a great pleasure for me to have the opportunity to share my work, and I'm very grateful to the organizers for arranging me at the earliest time slot. My presentation is about an open source code I developed called elASPECT. It is similar to Aspect in general framework, but replaces the Stokes equation with the displacement-based equilibrium equation in order to handle the elasticity-based problems. This is the outline. Okay, first, let's take a look at the differences in basic equations between Aspect and elASPECT. Since we don't have the incompressible condition in elASPECT, and we don't have to involve pressure as the Lagrangian multiplier, and the numerical treatments are also different. And these differences brings both advantages and disadvantages to elASPECT. The advantages includes the ability to handle compressibility and plastic dilation, and the unconditional stability with free surface. And on the other hand, elASPECT is not very good at simulating incompressible materials. The numerical behavior of Aspect and elASPECT will be compared at the end of the slices. For time-dependent problems, I adopt a quasi-static scheme, which is largely based on step 18 of Deal 2. The temperature and the composition of fields are transported with the convection equation, just like in Aspect. Oh, by the way, both Lagrangian and ALE schemes are implemented in elASPECT, but for now, the Lagrangian scheme has not been well benchmarked, so it is recommended to use the ALE scheme. And for the stress components, I employ a simple Wiener limiter to stabilize the convection phase, which, according to my experience, is effective and stable. elASPECT takes a PRM file for input, which is also similar to Aspect. But the major differences are in the material model section and the solver section. Currently, elASPECT has no user manual. I'm struggling to write one, but it may take months to finish. So if someone wants to use it, he may refer to the PRM files for the benchmarks. And now let's see the benchmarks. I present 4 benchmarks here.
You're muted.
Yep. Yimin, I'm currently muted. Could you unmute? Rena, I think his audio may have, I wonder if his audio went up.
Hello?
Yes. Okay, great.
Hello?
You're back. Wait, I can hear you now. I apologize. You were muted for a few seconds there.
Okay. Okay, I'll go on. And next one is the strip footing of the animation is stuck. I have to fix it. Okay. And the strip footing benchmark for elastoplastic rheology, and a pure shear test for the VEP material with a non-associated plastic flow rule, and a lithosphere compression and extension test, which is similar to the previous one, but with gravity and a realistic power law relation. For time reason, I don't make introduction here, just show the results, which are in good agreement with the analytical or standard results. Okay. Presentation. Now that the correctness of the code has been validated, let us see an application of elASPECT in an realistic problem. The subject is Enceladus, which is a small icy moon of Saturn. It is famous for the long parallel fissures in its south polar terrain, which are called tiger stripe fractures. The formation mechanism of tiger stripes have long been in debate. Most of the researchers think that the tiger stripes are a result from a tensile stress because they allow the water to come up to the surface from the underlying ocean. But Professor In An from UCLA suggests that the tiger stripes are more likely to be formed by a shear stress. And he was also the initiator of this study. But unfortunately, he passed away half a year ago due to heart problem, just at the time I finished the work. The goal of this study is to see whether the SPT can be formed with a simple shear. And it is now a paper under review. Our model is like this. It contains an ice layer and a water layer. The top is a free surface. We assume that the center area of the south polar is thinned due to tidal heating so that the plastic deformation can be concentrated at this area. And it is also one of the motivations for me to develop elASPECT, because the non-uniform ice layer causes instability when using free surface. And I failed to figure out this problem with elASPECT. And when using elASPECT, we can take advantage of its unconditional stability with free surface, and the work went well. Since the initial conditions are highly uncertain, we have explored a wide range of parameters to reduce artificial assumptions. If we pick different parts from different results and assemble them into one, we can see that the simulations have reproduced many of the geological features on Enceladus, including the finger-like structure at the corner and the hook-shaped bends, the arcuate fractures, and also we did produce the tiger stripes in one of the results. This animation shows the evolution of strain rate and plastic strain in our best fit result. And we can see how the radial shear develops at the initial stage, and how the tensile cracks propagate swiftly to the boundary of the model, and how the finger-like structures develop under a transpression stress. The major progress of our work is that we managed to reproduce almost all the prominent features on SPT with a dynamic model. And I think this research has brought new insights into the evolution of SPT. And finally, I would like to talk about my expectations for elASPECT. Now I'm trying to compare the numerical behaviors between aspect and elASPECT. This slide shows the results of a pure shear test from the famous book written by Professor Gurya. And it is interesting to discover that the result of aspect, the shear bands changes direction from this is Roscoe angle to other angle, while in the results of elASPECT, the shear bands changes from column angle to other angle. And on the other side, in this benchmark, aspect takes about 50 iterations per time step to converge to about 10 to the -4, while elASPECT takes less than 10 iterations per time step to converge to 10 to the -8. However, the situation changes in the strip footing benchmark with non-associated plastic flow rule. In this experiment, I want to investigate the bifurcation of shear bands with no regularization methods. And we can see that the results of aspect is fine, but elASPECT just failed to converge even with a direct solver. So I have to add a damper viscosity in order to get a result. It is surprising to me to find out that elASPECT is beaten in its strong suit. So I am trying to introduce the inexact Newton solver of aspect to elASPECT, and also to introduce plastic dilation to aspect, so that I can make more comparisons between them. And I believe that such effort can result in progress in our understanding of the numerical treatments related with plasticity. Okay, that's all. Thank you.
Thank you, Eamon, for that great presentation. And as a reminder for everyone, there'll be discussion and after the next talk. But in the interest of time, we'll go on to the next speaker. I just like to say again, Eamon, the developers and others have said this before, but this is incredibly impressive work, and this was a monumental effort to develop an entirely new code from aspect. So a round of applause for this incredible work, Eamon. Great. Great, and our next speaker is Kayleigh, I believe. I apologize. I only see on the Google sheet, I only see your first initial. Oh, could you raise your hand? Kian Lu. Sorry, are you the next speaker? Or no, I'm sorry, Kayleigh. Sorry, there you are. Sorry, I only saw your first initial on the list. But you're next, and feel free to share when you're ready. Oh, and you're currently muted. Are you able to share on your end, Kai? Oh, you're still muted. Oh, there we go.
I start share my screen. Yeah. Okay.
Excellent.
Okay.
And the talk is on inherited structures, on their impact on rift evolution, and the floor is yours, Kai.
Yeah, thanks, John. And hi, everyone. I'm Kai from Gifted, Germany. And today I will discuss the inherited structures and their impact on rift evolution. And this work is a cooperation with Sasha, Zoltan, Derek, Geoffrey, and Anna. Okay, and look at this map. My research area is the Southern Sea is located at the junction of the Pacific, Eurasian, and Indo-Australian plates. And firstly, let's focus on the within circle. It tells us the story. How does the origin change to the origin, and how to change from the origin to the origin, and especially in the world, most rift margins formed on origins, and during orogeny, the lithosphere undergoes thrust faulting and crustal thickening, leading to the formation of inherited weaknesses. If we compare with the homogeneous Leakic lithosphere with the reality lithosphere, we can recognize some inherited structures, such as suture zones, organic fabrics. So now we have a question: how do inherited structures influence rift evolution? And here are the seismic profiles collected from the northern part of the Southern Sea. We can recognize some thrust force are reactivated, and they are formed as the boundary of the sedimentary basins. But sometimes we will overlook the reactivation process because the inherited structures were overprinted by the latest deformation. Here comes our first question: and which circumstances are thrust force reactivated? Also, there are debates on the impact of inherited structures. For example, models considering the inherited structures, such as the fossil slabs, the models forms the asymmetric rift margin, but for the homogeneous lithosphere, they formed as the symmetric rift margin. So the presence of inherited structure is thought to define the location of rift initiation. And some models, they consider the various distribution of organic fabrics, but they could get the same rifted margin, and there's a deformation of the detachment force and with the exhumid mantle. So it seems inheritance may exert less influence on breakup. So here's our second question: could the location of breakup be controlled by inherited structures? The Southern Sea looks the map is a natural laboratory for inherited structures. It's because if we considering the geological background of this area, the Cenozoic rifting developed after a Mesozoic Andean type origin. And for example, the pink color there represents the Mesozoic volcanic arc, and the blue color they represents the Mesozoic sediment. So they all support the Mesozoic origin. And we plan to use the numerical modeling for this research topic. Firstly, we placed our model within the organic domain, and we apply the coupling of farscape and the aspect. Our model experience a sequence of tectonic events such as shortening, extension, and tectonic crisis by changing the boundary velocities. We also apply the strain softening and the various boundary velocities. Okay, and now let's look at the evolution of my model. During the shortening, it forms the thrust fault at a mountain in the center and the crustal thickening. When we change to extension, the mountain collapse. Some thrust force are reactivated. And after the crust breakup, it forms a wide rift margin. And what's more, we put 5 points to trace the PTT path, the pressure, temperature, time path. And yeah, let's look at it again. And we also recognized in this area the exhumation of the lower crust, the green point. So our model reproduces a range of observed processes like the continental origin with an origin with a height of around 4.5 kilometers, the post-orogenic collapse, thrust force reactivation, continental rifting, and lithospheric breakup. So because our research area is a Southern Sea, we needed some observations to constrain our modeling results. So firstly, we define the LAB in our models with the isotherm with the 1,300 degree. And the LAB is comparable with the geophysical data across the northern and southern part of the Southern Sea. What's more, the borehole depth, the red line, is also comparable with the OBS data. And also the humid low crust and reactivation of thrust force are both recognized in our models and seismic profiles. So we think structural interpretations are reproduced successfully. Because we put points to trace the PTT path. So for this video, I will show the PTT path of the 0.1 and 0.5. Okay, and for example, the green point is a 0.5. It experiences two reheating process. The first one is during the shortening phase, and the next one is during the extension phase. Is because it's localized in the hanging wall. The displacement leads to the deepening of this point, so it experiences a reheating process. And on the right part, the pink color is the appetite fission trace data we collected from the northern part of the Southern Sea. And we draw 5 points, the time temperature path. So both data tell us there's a rapid cooling rate of around 5 degrees per million years at the initial stage of rifting. Based on the data, we can also think the thermochronological interpretations are reproduced successfully. Okay, based on the model evolution and also the constraint of our models, now we want to address the first question. It is about the reactivation of thrust force. Yeah, look at this fault. At the beginning, this thrust force is inactive. It's because it accumulates less strain, it's relatively strong. But later on, this fault is fully reactivated, and it deformed as a boundary of sediment basins. And we also recognize if the thrust force is in the areas which experience the thermal weakening, they have the high possibility to be reactivated. At the bottom, we define our force into 3 types. For example, the red color represents the fully reactivated thrust force. They accumulate sufficient displacement and form as the boundary of sediment basins. And we also analyze 7 models with different input parameter. It shows that not all the thrust force are fully reactivated. And at the beginning, the accumulated strain is dominant. But later on, the thermally inherited structures plays a critical role in determining the reactivation behavior of the thrust force. And now let's move into the second question. It's about the breakup location. Here's the input parameters of the 7 models. We changed them in the crustal thickness, shortening velocity, and erosion efficiency. We compared them both on the orogenic stage and the rifted margins. It shows the rift margins are totally different and is controlled by the breakup location. And during the orogenic stage, we marked the highest topography. Here's the topography, and here's the breakup location and the distribution of the origin. And if we focus on this line, all the models show that the breakup always happens in the crustal root areas. In these areas, they have the high topography, the thickest crust. And the reason is that this area has the highest topography, they have the high gravitational potential energy, and the high GPE could provide the gravitational force. In addition, these crustal areas experience the thermal weakening, so these areas are relatively weaker. So during rifting, they accumulate a lot of deformation. Thirdly, these areas, the thrust force has a high possibility to be reactivated, so they can also accumulate a lot of strain during the rifting. So the crustal breakup tend to occur in these areas. And based on our model results and the geophysical data and observations from South China Sea, we draw the evolution of these areas. In Mesozoic, because of the Paleopacific plate subduction, there's an origin with the thrust force, the crustal thickening, and a high mountain. And later on, because the rollback of the Pacific plate, the mountain collapse, thrust force are reactivated, and the breakup happens in the crustal areas. So later on, it forms a symmetric and wide rifted margin. So here are our take-home messages. Firstly, our models reproduce the first-order tectonic evolution of South China Sea, and not all thrust forces are fully reactivated. The thermal inheritance plays a dominant role. And the last one, the location of breakup is often influenced by inherited structures. Okay, yeah, thanks.
Thank you, Kai. Kai, the floor is now open for discussion on both Yimin and Kai on Kai's talks. So please feel free to put your questions in the chat or raise your hand. And again, both great talks from both. Thank you both. Matthias, go ahead.
Okay, thank you. Hi, Kai. Nice to hear you and see your presentation. Just one question. Do you have, or are you planning to do like 3D models? This question goes because probably also the orientation of the faults, the thrust faults, regarding to the stresses during the extension could be also a factor controlling the reactivation. What do you think about that?
Oh, yeah, I'm maybe because of the internet, I missed your question. And could you repeat it again? Sorry.
Yeah, of course. No, my question is simply that what are your thoughts about the orientation of the faults, the thrust faults during the extension? I mean, because you mentioned some of the factors controlling the reactivation of those faults. And so my question is that, and then if you are planning to do 3D models to see how the orientation of those faults regarding to the stresses influence on the reactivation.
Yeah, it's a good question. Actually, we plan to apply the 3D models, and now we also do some developing things, and now the main aspect can be used for our 3D models, and now I'm do some test. And another question is about the rotation of the force. Yeah, and now there's two arguments about the detachment force. The first one is about initially it has a very low angle. Another argument is that initially it has a high deep angle, but later on it changed to a low angle. But in our models, it supports the second argument. At the beginning, it has a high deep angle, and later on, because the impact of the inheritance, it changed to the low angle. Yeah.
Other questions for Kai? If people are thinking of their, okay, yep. Renee, go ahead.
Yeah, since Kai, since we're talking about your models, let me start with your presentation. I was wondering, you mentioned in the beginning that you use the fast-escape coupling of aspect for these models. Can you give us a sense of how much the surface processes are necessary or important for these models? So do you actually need the erosion and sedimentation? Does that have a feedback, or would a free surface work just as well?
Yeah, it's also a good question, and now it's also a part of my work till now. Yeah, we also changed a lot of models with the different surface erosion sufficiency, the high, medium, and low. And if we close the surface process after the shortening, and then we change to extension, it's difficult for breakup. So it makes a huge impact for my research. Yeah.
Oh, interesting. Good. Thank you.
Yeah.
I have a question for Yimin, but maybe if we have more questions for Kai, we stay with this topic and then move on later.
Yep, I think it's a good idea. Kai, I had one question. Oh, and I apologize, Sungho. I just saw your hand. Is it okay if I ask my question, and then we'll go to yours next?
Yes, sure.
Sure. Yeah, Kai. Thank you again for the great talk, and these are really interesting results. I have a question. Did you what I've seen in previous models is that the effect of strain softening, like the magnitudes of the plastic strain weakening and the viscous strain weakening, both their rates and magnitudes can have a really large effect on reactivation. Is that a parameter you've tested or a parameter you are thinking about testing at all?
Actually, as for me, the only thing I tested is the weakening, the plastic weakening and the viscous weakening, because in the input file, we can change it. Now my model is 0.25 for the plastic weakening, 0.5 for the viscous weakening. And I also test some values such as 0.5 for the plastic weakening. And my feeling for the first order structure of the rift margin after shortening and extension, they are comparable. So it doesn't make a huge impact for my models.
Interesting, great. One other note is that when you do get to the 3D models, send me, you and your co-author send me a message. I just went through the process of running the 3D models of rifting with the surface processes. We spent a lot of time trying to optimize the solvers for the runtime. So send me a message and I can pass on our experience, so you don't have to go through maybe some of the same testing again. And everyone else feel free to do this the same as well.
Wow. Yeah, thanks, John.
Yeah, of course. Yes, Sungho.
I have a question for Yimin. It was great talk, and as far as I understood, you use the displacement instead of the velocity. And however, is it limited to like the small strain assumption, but you are dealing with tectonic problem, very large displacement, but you don't use like the object stress rate. So does it have any problem?
Yes, it is a small string. Use a small string, and I use the quasi-static scheme like this step 18 in Dual 2. And for the ALE scheme, I have 3 phases: one Lagrangian phase, and one convection phase, and a rotation phase. So your question about the objective stress rate may be settled here, I think.
Okay, I see. So you don't have any like dynamic propagation anymore because you doesn't consider about the what is that? The inertia is going to be the 0, right?
No, I haven't taken inertia into account. It's quasi-static for now, but it's it won't be difficult to add inertia both in Aspect and elASPECT, I think.
Okay, I see. Thank you.
All right, thank you.
Other questions for Yumin? Yes, yes, Renee, go ahead.
Yeah, maybe follow up. I like John said, I think that this is very impressive work, and I'm curious a bit about the solver that you're using and the scalability of that solver. Can you give us a sense for the types of model sizes that you can run in elASPECT, and whether the solver is parallel? Does it scale to larger models, or do you have to limit yourself to like
Oh,
a shared
yes, that's a
memory
good
machine or
question.
something like this?
Yes, I have implemented, I use the most classic Newton iteration to solve the plastic models. And for the linearized system, I have implemented two methods. One is an iterative solver with GMRES solver from Trillianus, which is preconditioned with AMG method. And the other is direct solver, the MUMPS. And for all the benchmarks I showed in the slices, they are 2D problems, so I use the direct solver. And for the application about Enceladus, I use the iterative solver. That model contains about, oh, I forgot, but it's at least 10 million DOFs for displacement, and it takes about 1.5 a day to solve using CPU cores with 192 processors parallel.
So it is so the iterative solver in the structure is very similar to what Aspect uses, because we also use a GMRES with an AMG preconditioner.
Yes.
So in theory, it should probably scale in a similar way. I don't know. Have you done any tests how large you can make the model, or how many cores you can run it efficiently?
Yes, I'm trying to do this maybe in a few weeks.
Oh, okay, cool. I would be curious about the results. Thank you.
Thank you.
Yes, Anne, go ahead.
Very impressive, both talks. Yumin, that's really awesome work. I was wondering how much further what more you want to implement. For example, you mentioned that the Lagrangian part is not as benchmarked as the ALE formulation. So I was wondering how far you want to take this, and also since you've done a bit of comparison between Aspect and elASPECT, like what you think you can, like how Aspect can improve, for example, based on what you've learned from elASPECT.
How to say, I'm not quite certain about this myself, and for now I'm trying to derive the mathematics for Aspect using the consistent linearization to introduce the consistent linearization method to Aspect, which uses the Stokes equation to solve the deformation. And I've done the math, but to program, actually, it may not be so simple. And for elASPECT, this is difficult to expand it because I'm alone, and to add any new features may take weeks of work. So now I'm mostly focused on Aspect.
So we've been trying to improve on the viscoelastic implementation in Aspect, so with a group of people. So maybe it's good if we sit together at some point and talk about your experience as well.
Yes, I hope so too. And Wolfgang has just opened an issue about this, which is about a question of mine.
Cool. Thanks.
I will make, there are a couple more hands raised. I will make as one follow-up point on Anne's question is that I'm wondering, Yamin, if implementing the consistent tangent operator method into the regular aspect framing would dramatically improve our convergence behavior as well. I have no idea how I'm not sure how challenging that is, but that would be a great thing we could all talk about maybe at some point in the future.
Yes, yes.
Great. Hyunyi.
Yes, I also have a question to Yiming, but I kind of slightly change the topic, a more scientific topic. So I'm very interested in your result about Enceladus, the tiger stripe thing. So what would you like from your model result? What would you think will be kind of like the mechanism like that forming the tiger stripe? Because like yeah, maybe you have already mentioned that, but I may just miss it. Is it like, do you think it's like the tensile, like, is it like a tensile stress or it's more like a transform forward thing? So.
Sorry, I didn't catch. What is the
Oh,
transform?
sorry. Yeah, so what do you think will be kind of like that driving stress that formed the tiger stripe at the south pole?
Oh.
Tensile transform, or it's like combination or something. Sorry.
Oh, it's a good question. And for the tensile stress, there are many potential driving forces like the tidal stress, the diurnal tidal stress, and the NSR, and the freezing of the ice, and so on. But for the shear stress, I have no idea. It's just because of the geological features that are very much like resulted from the shear stress. You know, Yan was a geologist, and he is very familiar with this. And I've asked the same question to Maxwell, and he says that the shear stress may be resulted from the furry core of Enceladus.
So what is the like kind of the initial conditions of your model? Like, do you like apply any stress to your ice shell or?
The boundary conditions are the Dirichlet boundary conditions. It's a simple shear with a very small tensile stress. The tensile stress is perpendicular to the tiger stripes, and the magnitude of the tensile stress is 10% of the simple shear. Oh, no. It's not the strength. It's just the stress is produced by deformation. It's the Dirichlet boundary condition. Yes.
Okay. So you would say that it's like pretty small stresses will be able to form all the geological structure that we see. That's the result.
It's not small. The stress is not small because it's actually driven by the deformation on the boundary, so the stress accumulates until it reaches the yielding stress, and the ice shell will break.
Okay, so thank you for I'm looking forward to the real publications, and
thank you. Thank you.
Sung Ho, I see your hand is still up. Do you have another question?
No, I'm sorry.
Okay. Are there any other questions for Yamin or Kai? Great. If not, let's thank our speakers again for the great talks. And I believe the next item on the agenda is we will go into a session for general discussion topics. Renee, is that correct?
Yeah, that's correct.
Okay, great. I made a few slides. I made a few slides for this, so if it's okay, I will just share those just to start the discussion, and we can go from there.
Yeah, go ahead.
Great. So the general discussion topics were aspect 3.0. And Renee, I don't know if this is a topic you would like to lead. A second topic was one I put in was funding options for software development. So ideas for aspect, ideas for a CSI proposal later in the year. And then would a model repository, e.g. something like the IRCMC, be useful for aspect models? And Renee, I don't know if the third topic, did you put that in, or is that from Lorraine?
So I think Lorraine brought it up, but I can also lead the discussion or co-lead with Lorraine. Just introduce the topic.
Okay, great. How would we like to start? I mean, Renee, where would you like to start? Should we just go in sequential order and start with aspect 3.0?
Sure. We can also ask, can you put in a fourth point, which will just be general discussion or other topics that other people want to discuss? So the idea of this part is really that we can discuss whatever is relevant to the development of aspect at this point, what might happen soon, general problems or results that you had, or if you thought of any other questions for the presentations that we saw yesterday and what we should discuss in a bigger group now. So gather your ideas. If you have an idea for another topic, feel free to write it in the chat, or we'll also ask for topics once we are through the other three topics. The first topic, aspect 3.0, is really just a bit of an I already introduced that yesterday during the introductory slides, that we are thinking about making another version jump for the major version of aspect, which would involve a few incompatibilities, primarily to remove some deprecated parameters or rename them, make some changes to the core solvers, and I don't know if there's really much to discuss about this topic. I thought it was important to bring it up at this meeting to ask for opinions about that. In particular, if you felt that the transition from aspect 1 to 2 was smooth enough for you, if how much of a concern it is if parameter files become incompatible, how important it is to remove these deprecated features. If there are any concerns or questions, then feel free to raise your hand or unmute yourself and ask some questions. John, I think you're muted.
Yeah, I was just saying, I apologize, everyone. I'm trying to get out of screen sharing. It's not letting me get out of screen sharing, so I'm going to close my window and then hopefully
you
lets me come back.
You stopped screen sharing.
Great.
We don't see your
Great.
screen anymore.
Great.
I don't have a question. I just think it's a good idea to at some point make a hard break and change the things that need to be changed and remove those things that we no longer need. And I was wondering how much, okay, maybe that is a question, how much of, for example, the parameter file changes can be caught with this like script that we had last time as well, because I think that worked really well.
Yeah, I think
so this conversion script.
Yeah, I think the idea would be to try to make as many changes as possible easy to upgrade by just running a conversion script for the parameter file. We are working on an improved version of that, actually. The last time we used some simple text replacement tools to just replace parameter names, but they were very limited in what they could do. One new tool that that I think is already merged is we are now able to read in parameter files using a Python script into an internal data structure that can then reformat those parameter files. And one of the things that we are currently, for example, thinking about is all parameters for the particles are inside of the post-processing subsection. That's an historical accident because they were post-processors at first and didn't have any influence on the solution, but we are thinking about moving them into their own subsection, top level. And this update script could do that because it has this tree structure of parameters, and it could just grab that node, the subsection, move it in its own global subsection, and then write it out again. And we've tested the script already a bit on the tests. So we've run it on all test parameter files and also all benchmarks and cookbooks, I think, in order to unify the indentation and the comments and stuff like that. So we are reasonably sure that it's safe to use even for productive models. But we can't guarantee that we can catch all of the changes with that script.
Oh, but that sounds very useful, very helpful. And as long as we put a disclaimer in there, like no guarantee that it fully works.
Well, it's in the license terms of Aspect. We cannot guarantee that everything works as expected.
I think we should make the break, and while we're making the break as many other things as we can. No, not as we can, but that makes sense where we should change defaults as well. I mean, if people need to update, maybe then it's also an opportunity to fix some of the defaults.
Yes.
I cannot really think of a lot of things right now, but maybe you all can think of some other things where the defaults are surprising or weird. One thing that comes to my mind is that like adaptive refinement is on by default. That's something that maybe is not the right thing because one has to really look at it and tune it to be sensible. I don't know if that makes sense to have like a better experience.
Yeah.
I really like that idea. I wonder if we could make, I don't know, an issue or somewhere where we collect all of the defaults that we, right, whenever someone, right, I'm also thinking about something like number of particles in the model or things like that, where it's like, right, there are so many things where I think we found some other values would be more useful defaults, and it's just so hard to think of them.
Yeah. Maybe we can start an issue.
And I wonder if it's even possible for different features, depending on if you're using, let's say, a simple material model or something like a viscoplastic or melt material model. If there's different defaults, we could, if there's different defaults that can be enabled based on what's happening. I'm not sure if that's possible with the current infrastructure of Aspect. For example, I'm thinking that the solver settings you would use for, let's say, a simple manifold connection model versus a complex tectonic problem are very different. Or maybe we can just put those recommendations in the manual. I'm not sure if it's possible to have select defaults based on what options you're choosing in the model, but that's for later discussion.
One other change that comes to mind is that is kind of my dream goal would be to make the GMG preconditioner the new default solver because it's so much faster. And by now it can do almost all of the features, the limitations.
I want periodic boundary conditions, please.
Questioning look towards Timo.
But I mean,
sorry, what?
Periodic boundary
conditions for the GMG.
We are close. Yes. There is work going on in deal 2.
That's really cool.
Yes.
I mean, there are also still issues with the GMG and switching between cheap and expensive.
My answer to this is we probably shouldn't switch between cheap and expensive. I don't see a good reason to do it, but yeah, this is still broken, I know.
But right, that's one of the other defaults. We can just set the cheap to 0 and the expensive to, or no, what was it? The cheap to 1,000 and the, well, right, whatever. Yeah, but that's one of the other defaults, right? We should write it down immediately.
Yes.
I can make an issue and write
Perfect.
that down.
Perfect.
And the second thing is that there are still issues when using GMT with Newton solver, but since Newton solver is currently, or the vector correction solver, given that that's currently not the default, that might not be a blocker, but just to mention. But I mean, I like that. I mean, I'm not sure if that's possible with the current infrastructure, but I like John's idea of having different default values for different things, especially with the solvers, because for the vector correction solver, some of the tolerances mean something completely different than with the full Stokes solver. But yeah, I
So
think that would be kind of hard to implement. So that would probably be a recommendation.
it is technically possible to modify a default value once after it has been read in. So we can only specify one as the default in the declare parameters function, but we can of course change it afterwards. But that would be very confusing because then on the website we list one value as the default, but if you set another setting in a different way, then suddenly that default is not honored and it's different. That seems to me more like we should think about having different parameters for those different solvers. Like not reusing the Stokes solver setting for the defect correction solver, but instead having the own defect correction, a separate parameter for that.
That might be a good idea. Split that.
Maybe something we should discuss at the hackathon in the summer.
Would we want to release 3.0 before the hackathon?
So ideally, we like to make a release before the hackathon so that we can release a relatively stable version and then start breaking things at the hackathon. We could change that this year and say we finalize 3.0 at the hackathon and then release it afterwards.
I want to ask something about the material model. Okay, Renee has told me that you have planned to change the structure of the material model, and I found recently that according to my revision, there are some small problems in the Newton solver with elastic rheology, and to fix this, we have to make the elastic model exposed to the public. So maybe we have to add something like elasticity handler, or I don't know. So
yeah, I don't know. I don't know the full context of this, but I think what you're referring to is we kind of have sub-modules introduced into the material model where we separate out the rheology or the equation of state from the large
yes, that's a way.
Material model.
I'd be curious, Eamon, what information from the elasticity rheology module do you need for the Newton solver?
In the Newton solver, you should we have to compute the derivative of viscosity and multiply it with the strain rate from the previous nonlinear iteration. And when elasticity is taken into account, the strain rate you multiply to the derivative of viscosity should be the viscoelastic strain rate, not only the strain rate.
Yeah.
So to compute the viscoelastic strain rate, we have at least we must know the shear modulus, but it's inside the class rheology elasticity, so we have to make it exposed to the public.
In in the revisions we've been doing for the rheology models, I think we ask a lot of information like this from the material models as well. So maybe that is already exposed, like in the shear heating, for example, we also need to compute a different strain rate. And there we also question the material model for several stress-related parameters. So maybe this is already resolved in this new formulation.
Oh, sorry.
But it's
I
certainly
didn't catch it.
something. So I think what Anne is saying, maybe this will already be solved with the rework of the elasticity. So maybe it will be available once that work is finished. But if not, we should definitely look into how to make that available. And that should not be a change that is especially incompatible with anything else. So we can certainly look into that. If you let us know what kind of information is needed, or prepare a little patch that just exposes that information, that should be possible to merge.
Okay. By the way, what is the time of the next bi-weekly meeting of Aspect?
That is a great question, and thanks for bringing that up. For a few years, we have introduced bi-weekly meetings for the Aspect community. It's like this workshop, but a bit smaller and a bit shorter. Every 2 weeks, we meet for 1 hour just to discuss whatever is happening. And oftentimes these meetings are short if there's not much to discuss, but sometimes we need the full hour to answer questions or discuss ongoing development. We used to do these meetings on Wednesdays, but for this year, we had a poll among the maintainers, and Mondays work better for all of us. Does someone have the time in whatever time zone available right now? I would have to look.
Yes, I believe it is next Monday.
8 Pacific
European.
time?
Oh,
Okay.
8 Central European time, 2
8.
p.m. Eastern time.
Okay, so 2 p.m. Eastern US time. 8 p.m. Central European time. And I would have to convert that to see.
11, I think, Pacific.
Yes.
11 Pacific, yes, but I'm not sure which time zone that is in China.
It is very late at night. Unfortunately, it is very late at night. So Yemen, perhaps we can arrange a separate time to meet at some point. So you do not have to meet at 1 o'clock in the night.
Thank you, but it's okay for me since it's only once or 2 weeks.
And I think according to the schedule, we would have the next meeting next Monday, but since we have this workshop this week and several of the developers are on a different workshop next week, I think we will skip next week and continue on February 26th.
It's a
according to
federal
the
holiday.
No, not 19th, the 26th. So essentially in 2.5 weeks. But there will be an announcement in the forum about that meeting. About the Friday before or the Thursday before, I will send an announcement in the Aspect forum. Okay, if you want to follow the development of Aspect 3.0, then feel free to attend some of those meetings, but it's completely optional, or if you have questions about your models, feel free to come. They're usually pretty informal. John, I think in the interest of time, we should probably move on to the next discussion topic.
Okay, sounds good. Yeah, and I'll share again. I apologize. I can no longer access my camera, so I can't see who has a hand raised, but I'll share again. And so I would say the next topic I would propose we maybe discuss what having a general model repository. And Lorraine or Renee, would you like to lead that discussion, or I can have provide a brief overview of the idea?
Yeah, I'm not sure who is best qualified. I think so. Lorraine, correct me if I'm wrong, but the idea is essentially that CAG wants to provide useful services to the community, and one idea for these services that came up is to host model workflows and/or results that might be of interest to others users. So say you run a complicated model, it's connected to one of your publications, but there are lots of other things that you could do with that model, but would never do because you are moving on to other topics or you're working on a different question. So it could be useful to post these model results online so that others can compare their models against it or use that to derive a new study with other questions. And IRIS EMC is the Earth Model Collaboratory. I'm not actually sure what the C stands for. Collection, maybe. It's a website that IRIS hosts for seismic tomography models, where you can download all kinds of different tomography models in a unified format that you can use then to answer scientific questions. So the question is essentially, would something like this, but for aspect models, be useful for our community? And keep in mind that it's easy to say yes, but it will involve effort on the part of CAG that then cannot be spent on something else. So the question is the effort worth the result of having something like this available? And I guess at this stage, we're mostly looking for feedback for, do you think that is something you would use if something like this existed?
So
what are
there's
thoughts about it?
Yeah, so there's various parts of this, right? So there's the input models, that is, sometimes people create models, input models that other people can adapt or use in their simulations for different or similar problems. And there's the output results, right, to compare results. Yes, as Renee said, would people find a repository useful for their work? I forgot what I was going to say about this. And I think, I don't know, you know, on the contributor end, how much extra effort this would be. A lot of this is already being required by journals, for example. So it's probably something relatively straightforward, we would think, but it would, of course, require some effort.
Thoughts on this from everyone? Yes, Juliana.
I mean, so like just to clarify, like how would that look like? Because right, if it's so for storing the inputs for models, usually right there are options like Zenodo or things like that, where that are already possible and that are easily findable from the paper, right? So if you publish a paper and want to link sort of how did you make the models, that's already easy to do. And the challenge that I have and that what many others have had is that some journals require also storing some sort of output depending on sort of how you interpret the policy. But then you have a terabyte of model outputs. And then, right, that is the question if you can store that somewhere. So now, right, on the one hand, I don't, right, is that something you're thinking about? Right, that would be a lot of space. It would be a huge amount of space. And I don't know if that, right, it could potentially be useful for others to get these huge model outputs, because those are models that are really hard to reproduce because they probably took a long time to get these results. But on the other hand, right? Is that really the kind of infrastructure that you're thinking about for these huge model outputs?
Yeah, I think it's undefined. It's really trying to define what the space is and what the needs are of the community. This is a problem that we sort of encountered first with the Rayleigh project, because Rayleigh did produce terabytes of data from their Insight project. So the question is there something similar like that that exists in the Aspect community that people are looking for and need? And of course, this is not, when you're talking about data storage, this is not a cheap problem to solve.
I think this would be incredibly useful for like the large models, which other people in the community might want to reprocess us for their own purposes. So for example, like a massive 3D simulation, and which run on something like Frontier, ideally, there could be lots of data mining from that. But there's no really realistic place to store this. I mean, for like in the UC system, there's like the California Digital Library, but if there was a common place, even if there was a fee associated with it, as long as we knew what the fee structure was, people could write that into grants. And if there was the option to then store it there, and then people could access it and download it without having to use us individually as an intermediary, or potentially even visualize it. Like if there's some interactive visualization options with like PairView or something on this thing. I think that would be a fantastic option, while acknowledging that, yes, I'm sure this sounds like an enormous amount of work, and this does not sound trivial in any capacity whatsoever. Because either Julian or Lorraine, as you said, journals keep asking for this, and there's basically no easy option to store the data. I mean, this occasionally pops up. A journal editor asks me they're like, where's your model output? And I'm like, well, provide me a solution for storing 10 terabytes of data, and I'll happily put it somewhere. But right now, there really isn't an option. Yes, Juliana.
Sorry, is my hand still raised? I said everything I wanted to.
Okay.
I just wanted to mention Antoniette posted a great link in the chat that links to a project that looks somewhat similar, but funded by the Australian research agency, that apparently allows to upload some model results, even if they are reasonably large. So we could think about if that is something of the sort that we want to have. And it might even make sense to ask them what kind of effort that was and if a collaboration would be useful.
Yeah, it's part of elasticity, and I think we saw some models that look like rifting, so I'm sure Louis is probably involved with some of that as well. Dan Sandford. Yeah, so that's the underworld group.
But so I couldn't find quickly information on whether you get a DOI or whether this is permanent storage, or like what guarantees they give, or what are the maximums of files. And they say you can upload images and text files that showcase your work. So I'm not sure if that includes like actual data.
So if you go into any of the models, there is like different tabs of like an overview, model setup, model code, and output. And there is basically links to all of this to like, I don't know, in different places where you can find the code itself, which is not on this website, but you can find it into like, I guess it's like some national catalog or whatever. As far as I saw.
Yeah, thanks for pointing this out. This is like a great resource, and it's definitely a great model, at least for what I was thinking of.
So I mentioned it because I was just at the University of Sydney 2 or 3 days ago, and we were talking about this. And I think that the model that you mentioned, the elasticity-based model, is something that I would like to see in the future. But I think that the problem is that as far as I understand, I think you can store the output. I'm not sure like how much, what the size is of your output. I'm assuming there might be a limit. But you definitely get a DOI. So that was like part of the whole issue, that you do get a DOI for your models essentially. So to be like a companion to the DOI you get from the paper.
That's great. So very similar in concept to Zenodo, but maybe there's expanded storage options. Like there's a larger capacity, and it's more tuned for Earth or geodynamic or Earth science models. This is fantastic. Thank you, Antoinette. Are there other comments or suggestions or ideas on this topic about a model repository?
A question for you and Julianne is like, when you talk about large, I mean, exactly how many terabytes are you talking about? I mean, what is that range?
I mean, I can give one example on my end, and then maybe Arushi and Timo and Julianne and Renee can speak to the large 3D instantaneous global models. But for a large scale 3D rifting model with particles, in some cases, I generate 5 to 10 terabytes of data for a single model. And so it's really massive. Juliana or Arushi or Renee or Timo, do you know off the top of your head the size of some of the models from the FRES project for some of these global simulations?
Yeah, because they're instantaneous, they are 32 to 64 gigabytes.
Yeah, so right, I think this is more an issue for the time-dependent models where it depends on how many output steps you store. And for me, it's usually been something like 1 to a few terabytes for the whole study. So smaller than what you mentioned.
Can I ask, how do you handle this, like these big models afterwards? Because like, I mean, just trying to visualize, I have problems even trying to visualize a simple subduction model sometimes. So
I mean, I can say for our models, our supercomputer has a graphical user interface where you can say how much memory do you want, and then that sort of solves the problem.
Yeah, it helps. I have on my end, I have a very high-end desktop specifically for visualization, which is basically the equivalent. I mean, this is almost the equivalent of sort of what Juliana was speaking of. So it has like 128 or 256 cores, but then like a few, I think it has 2 to 4 terabytes of memory, but then which is effectively the same solution as what Juliana is speaking of. But yeah, it's still a major challenge, and you have to tune your pair view settings correctly, because if things aren't set up in pair view correctly, it can be really, really inefficient.
Yeah, one important piece is to enable the parallelism in ParaView, to have MPI enabled in ParaView, and to make sure that you have enough output files per time step, so that there's the setting that you can choose how many output files you want for each time step and how many groups that should be split. And I think the default is 16 or 32, which is completely fine. It means you can use 16 or 32 cores in parallel to visualize this, but you have to enable that setting in ParaView. Otherwise, ParaView will just use 1 core to visualize the model, and that will take much longer.
So what about input models? Maybe this is a question for the world builder community. Whether or not that's also sort of a need.
Well, I mean, input models should be with the paper anyway, shouldn't they?
Right. So the question is similar to when we're looking at this website, that it really provides a redirect service, right? So it directs people to appropriate resources.
I can provide some feedback here, Lorraine. I've never had an issue with storing the inputs for models. I think it makes sense for maybe if there was a model repository set up, I think it would make sense to either have the outputs and inputs be stored in the same place or linked to where the inputs are. But in terms of the size of the inputs, I've never had an issue. I've always been able to use Zenodo. I've never exceeded the Zenodo limit. So at least right now, I don't think there's a technical hurdle to storing the inputs right now.
Yeah, I was thinking more about being able to find them more in an easy fashion and not necessarily strictly related to a storage problem.
Yes, in that case, that would be great. I agree, that would be great if there's a way to easily search through, basically, for the inputs through all the different aspect or other model papers.
So would you?
Oh, go ahead.
I was just wondering, because for me, the workflow of having everything, not just the code, but also input files, output files, post-processing scripts in a Git repository, push it to GitHub, and then say to Zenodo, make this into archive this as a repository. So that works quite well, and you can store some part of your model output as well, right? Like part of your output. But then, are you talking about storing those things, part of those things again, or redirecting to a Zenodo repository?
It would be some sort of redirect. I don't think we're talking about storing multiple copies of anything. Of course, the issue always with GitHub is that it doesn't have a DOI associated with it. And actually, your repositories are a great example, I think, for the community when people are looking to make available their data for journals.
Yeah, but I basically just wanted to say the same thing. The way it, like in this website that Antoniette linked, the way it's done there, it's also that it basically redirects, or it can redirect to another place. And I think that's a good solution, so that you can find everything from one place, but then it's stored to wherever you would upload it anyway.
And hopefully make it easier searchable for the types of models that you may be interested in as well. So.
Yeah, so it's like has two benefits, like you get more exposure of your work, or another outlet of your work, other exposure outlet, and people can search for similar or for things like model setups or outputs that they need or could reprocess.
Yeah. We had the citation list, which is essentially kind of duplicate, but you'd have to still like filter through that. So. I think I've gotten good input. I know we're heading towards the break, so I want to make sure we get to the next topic. So if there are any last words on this, or just contact me directly, or we'll bring it up again in a developers meeting.
Thanks, Lorraine. And I think we have 5 more minutes, so I think we can just briefly touch on the second topic. So this is basically feature aspect development. And I prepared just 3 quick slides on this, but basically the idea is that development of major new features in Aspect and other codes originally previously supported by CIG are no longer supported by CIG. CIG's mission has changed, and it's more focused on education, outreach, and then maintenance of the current code, stated code. So current and future development is occurring through either science-driven proposals or in some cases potentially software infrastructure proposals. So as an example of the latter proposal, there was in December a proposal submitted to couple Aspect with a redesign implementation of LandLab, and this was to the NSF CSSI program, and the distinction there is then the outcomes and the products of that proposal over an extended, I believe it was a 4 or 5 year proposal, it's implementing features to allow people to do science. So then the science itself, or answering specific questions is not the goal, but is to create the infrastructure for people in the future to answer those questions. And so there are 2 very different classes of sort of proposals. As another example, Deal 2 has been funded under the CSSI program. So the Aspect development team, we've been tentatively discussing submitting a CSSI proposal at some point this year or future years to fund development of new features or improvement of existing features in Aspect. And so I won't go through all the points I've made, but so an example, this is just something I came up with, is I thought of all the different type of problems I'd want to solve in the future. So sort of thinking about frontier research. And if we think about all these different features right here, again, this is just a list I came up with last night, is things like race-ate friction, improved representation of grain scale process, new methods for plasticity and elasticity, anisotropic viscosity and faults, reactive fluid transport, high diffracturing, and then coupling all those things together. That's an enormous amount of work. And when you actually start to put all those things together, even individually, you probably need to develop new numerical methods to make integrating all of these things possible. So at a sort of a development of these features and integration of these features at this scale, it's maybe not necessarily a good target for a science-driven proposal, but it's a larger scale software infrastructure proposal to basically make sure implement these features, or make sure they're integrated, make sure they're working, so then people can use them in the future. So the question I wanted to bring up to everyone is the following two questions. First is, how can the Aspect developer team in CIG help support the proposals you want to submit and the features you want to develop? Because now the model going forward is everyone should be, and in the past this has also happened, is hopefully there's a large community of people contributing to Aspect and proposing to fund new features in Aspect through NSF or other funding agencies. And then sort of a second part to that is, what features would you like to see worked on by the developer team, and what features should potentially go into a large-scale CSSI proposal that is not a good fit for a science-driven proposal? So something that would maybe require a couple of years of software engineering support. So something that's maybe out of the scope in sort of the level of difficulty of the normal science-driven proposal. So I realize we only have about 3 minutes left, but I will now open the floor to everyone's thoughts and opinions here.
Maybe to get started on the first question, I just wanted to make everyone aware that on the geodynamics.org website, there is some sample text that you can include in your proposals if you want to use CIG software, and make sure that the reviewers are aware that you're using community software and how CIG is linked to that. And if you want more support from CIG, then feel free to contact me or Lorraine for what CIG can or cannot do. I can link the website in the chat, but this is more like this is broader. This is essentially to include CIG, not specifically the Aspect developer team.
Thanks, Renee. And then, yeah, I apologize. I should have put that. I forgot to put that link into here. I had meant to do that. Yes, Timo, I see you have your hand raised.
Yes. Being part of the Deal 2 CSSI, I have some thoughts about this. So I think if you want to fund not science research, but software development, I think you have kind of two approaches. The one we use in Deal 2 or have used in Deal 2 is the following. The CSSI project is basically saying, we support the Deal 2 project and build the community and do things what the community wants and needs. And so specifically, this was not a list of we implement A, we implement B, we implement C, but rather we do workshops, we ask the community what they need, we help them, we do review, we write tutorials, we make videos, etc. That's also an option we have for Aspect. That would be broad, include many of the main developers, and be big typically, right? Of course, there's an overlap with CIG and the hackathons, whatever, so that it has to be different than in Deal 2. But this would be the generic way of saying we want to support the software project in general. You can put features in there as well, but I think that's not the main thing. And then the other way that I see is you pick from your list, John, and say, I want to implement X. And that is typically a smaller project, fewer people involved, and focused and then also the smaller type of CSSI project. And it has been used for elASPECT as well in the past, right? Gary has done this, for example, with success. So I think these two strategies make sense. And that's something what one can think about. What is the more appropriate thing to do, and who wants to be involved, basically.
Yes, Juliana.
Oh, I just wanted to ask Timo, right, based on your experience with DL2, how do you deal with anyone who is not located in the US? Right, I'm just thinking because the majority of the aspect maintainers will be located in Europe and not in the US. So, right, the question is, can we still figure out a way to write just one proposal, or does it make sense for the people in Europe to figure out what would be the right funding agency in Europe to get money for developing aspect?
Yeah, so there are some collaborations between NSF and European agencies. I've never applied for anything for this. In DL2, the only support our European colleagues get is they come for a visit and we invite them in the workshops or hackathons or developer meetings. That's the only thing we can do realistically, at least as far as I understand in CSSI. So one can think about there are collaborative international things, or the answer is people in Europe submit something to their agencies for certain features, and people in the US submit something for other features in the US, and then this is what it is. It's everybody hopefully gets some funding. We can explore the collaboration things, but yeah.
I think, right, I've made experience with NSF NORC, which like submitting proposals for that works reasonably well, but it's just with the UK. And I haven't seen anything that's collaboration with Germany.
Yeah, I asked Julianne that there was at some point last summer, I think I asked the CSS, I asked program, I think it was really Martin, who is the director of geoinformatics. My understanding is that CSSI currently doesn't have the arrangement with NERC. So it's only certain agencies at NSF where you can have a joint thing with NERC. So there's the CSSI options are unfortunately even more limited. Maybe that's changed in the meantime, but within the earth science programs, you can collaborate with NERC, but not with CSSI right now, is my understanding, which is really makes it even more challenging.
It is possible that there's collaborations with the ERC, and the UK is part of the ERC, so all of the European countries can participate. But I mean, whether that's worth it or not is a different question, right? I mean, is it more likely if you write separate proposals with perhaps a substantial overlap in text to both of these funding agencies, or do you really want to couple it and submit it to both at the same time? Not sure.
I think the ERC, right, you would have to write an ERC synergy grant, which first can only have 4 PIs, but that's right, that's the only one where you can have different PIs from different institutions, and then that's super competitive. So I think the chance for that getting funded is just really low.
Well, the question is the chance any higher if you had a proposal that went both to NSF and the ERC?
Intuitively, it would mean that they have to both succeed for any of them to succeed.
Right, so I think the way it works in ERC, and people who have more experience with funding in Europe can correct me, but so they have programs for early career scientists, which most of the aspect maintainers still are. But if you try to write something that's collaborative, you compete with everyone. You compete with all of the senior scientists, and that's the challenge with that. So right, if I submitted my own ERC proposal, that would have a better chance than if everyone else submitted their own ERC proposal.
So it sounds like, and so like at the high level, maybe in a couple months we can, and maybe at the aspect user meeting or the biweekly aspect user meetings, we can revisit this topic and think about strategies over the coming year about even, I guess. So the first question would be is where is the best place to submit, even before we even get to start thinking about what exactly we want it to focus on. A reasonable question to ask is what is the best target? What is the best targets for funding these things? For everyone else here, I realize we're 5 minutes past the break, and I realize people are going to need a break soon. Are there any other thoughts people have on what features that you think would be really helpful to add to Aspect that would be difficult to sort of add on your own, like if you, let's say you had your own NSF or other grant and you had a couple years to work on this, that are there features you want that may be difficult to add without significant support from, let's say, the Aspect development team or others? Are there basically features you would want in a large scale CSS, like cyber infrastructure type proposal, that would be difficult to add otherwise? So what is your wish? So in other words, what is your wish list for things to be developed in Aspect? I don't see any hands raised. Does that mean everything you want in Aspect is already there? Or maybe I covered it all in the previous list. Okay, well, if there's no more thoughts on this, maybe this is a good time to take a 30-minute break. And I believe so. The next session would start at at the top of the hour. Is that correct, Lorraine?
Yeah. So
okay,
24 minutes.
Sorry to eat into everyone's break time. All right. Thank you again. A final round of applause for our two speakers, and we'll see everyone at the top of the hour.